Here are your notes for geometry, section 4.2, day 2. I split them up, try to make it a little bit shorter of notes and assignment. We are now going to prove that the triangles are congruent. We're in first half of the section 4.2. We said that they already were congruent. How are we going to do that? We have to provide the missing congruent sides and angles with their reasons. So they're going to give us most of the 6 parts. Remember, 3 sides, 3 angles for 6 parts altogether. We have to come up with the missing ones, but we need a reason for it too. So have your cheat sheets out and handy and ready to go with this. Once we prove that they are congruent, then we're going to write a congruence statement. So take a look at these 2 triangles. They should have 6 total markings on them, which they do. They have congruent sides, congruent sides, congruent sides, congruent angles, almost congruent angles. These aren't actually marked congruent. I know that you know in your head that they're right angles, and if they're right angles, then they have to be the same size, which means they're congruent. Okay, so your head is working when you say like, yeah, but they have to be congruent because they're both right angles. There's a reason for that. We're going to go find it on cheat sheet 4. Go look at cheat sheet 4 and see what anything has anything to do with right angles. Because we still need to list or point out the missing congruent statement is angle B is congruent to angle E. Now, if I were a stickler, which I am sometimes, I know, but I'm not going to be this time, I would make you write angle A is congruent to angle F, angle C is congruent to angle D, segment AB is congruent to segment FE, segment BC is congruent to segment ED, segment AC is congruent to segment FD, and you'd have 5 congruence parts listed, and this would be the 6th list on the list. I'm not going to make you write them all down. You can see them. Here's the 6th piece of missing information. Why is angle B congruent to angle E? Look it up on your cheat sheet. All right, I'm back. You found it. If you look at cheat sheet 4, it says something about right angles. And those right angles say, I'm going to put it right here in front of you. If 2 or more angles are right angles, so we don't have more, we only have 2. If 2 angles are right angles, then they are congruent. We have the if in the picture, we don't have the then until we write it down. It's called the right angle congruence theorem, and yes, you have to write that all down. If you want to complain, I can make you write all of that down. I don't. I only make you write the title down. Angle B is congruent to angle E by the right angle congruence theorem. Spell congruence right, spell theorem right, spell right and angle right. I wouldn't make you spell it correctly if I didn't give you a cheat sheet, but if I give you a cheat sheet, you have to be a good, I always say spell it right. You don't have to spell it right, you have to copy it right. Copy it word for word from what it says right here. All right, let's take a look at the second one. There's a couple of pair of triangles. One of them is a little inverted with the other, and if you look carefully, we have 1 pair of congruent sides, 2 pair of congruent sides, only 2 pair of congruent sides? We need 3 pair of congruent sides. Triangles have 3 sides. Let's find our angles. Angle, angle. Single arc, single arc. We've got 1 pair of congruent angles, and, oh, there's another pair of congruent angles. So we have 2 pair of congruent sides, 2 pair of congruent angles. We don't have a 3rd side, we don't have a 3rd angle, which means we need 2 statements. Let's work with that side first. If you're looking at the 2 triangles, we have triangle QRS and triangle QTS. Okay, they are connected. They actually share a side. If I trace triangle QRS and I trace that with triangle STQ, I actually have the same side twice. QS works for the left side and the right side. Left triangle, triangle on the left, triangle on the right. Which now we finally have a use for what seems to be that silly property. Why would you ever say something is congruent to itself? Because you need to say that segment QR is segment QS is congruent to segment QS. Why is it congruent to itself? Because you need it for this triangle and you need it for this triangle. And the reason, go find it and spell it right. Reflexive. You don't know how many times in all my years of teaching that I've had somebody write down reflective as if they were looking in a mirror. We're not looking in a mirror. Reflexive property. And yes, you have to write property or it's going to get marked wrong. It is the reflexive property. So now we have our three sides, and notice I marked it. Go ahead and mark it right away as soon as you find it so that you have a single, a double, and a triple. We have a single, a double, and now we need a triple mark for angle R. We know what's got to be left is angle R has to be congruent to the only angle that's left, which is angle T. Why in the world would those angles be congruent to each other? We've got our first angles, we have our second angles. Why are our third angles congruent to each other? Why are our third angles congruent to each other? Go find it on cheat sheet 5. It is the third angles theorem that lets the third angles be congruent to each other. And lastly, we need two more statements for this one, because if you look at it, we only have two congruent sides and two congruent angles again. But they gave us a little piece of information that might help us out. It says P is the midpoint of segment LN. Okay, you and I both know what a midpoint is. We learned that in chapter 1. Midpoint means it's right in the middle. Well, if something is right in the middle, then you probably cut it in half. If you cut it in half, the two halves are the same. And the same means congruent. So you already know by looking at this that those have to be congruent, but there's a reason for it. You need to state that segment LP, triple arc mark, is congruent to segment PN. And there's a dead giveaway of why those are congruent. It told you right here. P is the midpoint of segment LN. If P is the midpoint of segment LN, go look up the word midpoint. I bet you'll find it in the definitions list, cheat sheet 3. Go find cheat sheet 3. You've got words like congruent, bisector, midpoint, perpendicular. Wait, what did I say? Congruent, bisector. Oh, there it is, midpoint. A point is a midpoint if and only if it divides a segment into two congruent segments. Or we could make it an if-then statement. If a point is a midpoint, then it divides it into two congruent segments. If a point is a midpoint, then it divides it into two congruent segments. And you are going to write it as the definition of midpoint. Definition of midpoint. I did abbreviate definition right here on some of these cheat sheets, but then it doesn't let you do that when we use technology. It lets you use it if I grade it, but not in technology. So you have to actually spell out the word definition. Definition of midpoint. So we've got three sides congruent now, but only two angles. I wonder why the third angles would be congruent to each other. Any idea? Why would the third angles, let's think. Why would the third angles be congruent to each other? Because of the third angles theorem. But let's go find that third angle. We've got angle L, we have angle M, we don't have angle P. But we can't call that angle P, because if I said angle P, how would you know which angle we were talking about? There's an angle over there and there's an angle over here. We have to call it angle LPM. And of course, those of you that know what you're doing, angle MPL would be fine also, as long as the P, the vertex is in the center. Is congruent to angle, now we go this way, NPM. Again, vertex in the middle, NPM or MPN. Order doesn't matter when we're talking about angles. Order doesn't matter when we're talking about angles, but it does matter when we are talking about congruent statements. We did this already in section 4.1. Now that we have provided the missing congruent sides and angles, we need to write a congruent statement. We'll write that over here in green. Your choice on how you want to name this triangle. I'm going to call it alphabetical order, just for some sense of order. Triangle ABC. But then angle A has to match with angle F. Angle B has to match with angle E. Angle C has to match with angle D. There is a full congruent statement. If you rearrange this order, you have to rearrange this order. You wanted to call it triangle CBA. Fine. Then call this triangle DEF. The parts have to match. Don't forget your triangle symbol. Put the congruent in between. Second one, name the congruent statement. Careful on this one. I'm going to go triangle SQR. Why did I choose to go SQR? That's not alphabetical. This time I chose single arc, double arc, triple arc. Single arc, double arc, triple arc. Well, then on this triangle I have to go the same order. What has the single arc? This time the Q has the single arc, S has the double arc, and T has the triple arc. The S's, notice, do not match up. The Q's, notice, do not match up. You don't say Q is congruent to Q because in this case they're not. This triangle is completely rotated around, flipped around, inverted, however you want to say it. So this S triangle matches that Q. Be careful and follow your markings. Last one, I'm going to call this triangle LPM. Start over here, go across the bottom, go straight up. Which means I am going to work with triangle L has to go with N. P has to go with P. In this case, it is the same angle, triple, triple. And M, again, same, single, single. The M's actually match up with each other. There's your congruent statement. Let's try this one. Prove the triangles are congruent. Same question. Provide the missing congruent sides and angles with their reason. Then write a congruence statement. Provide the missing congruent sides and angles. We have one pair of sides, two pair of sides, three pair of sides. Three pair of sides, no pair of angles congruent, which means we need three pair of angles congruent. We're missing three statements. We got to come up with them on our own. We're close. I know what you're thinking because I am in the heads of geometry students that I've taught for years and years and years. You're thinking, well, of course angle P and angle M are congruent because they're the same size. Yes, angle P and angle M have the same measure, but they don't have arc marks on them because you have to turn same measure into congruent. How do I turn something that has the same measure into something that's congruent? You go look on your cheat sheet in the definitions. Let's turn that into a conditional statement. If these two angles have the same measure, then they are congruent. Go find it on cheat sheet 3. Keep looking. Keep looking. I'm not giving it away. Go find it on cheat sheet 3. Hopefully you didn't look too far because it was the very first one. Oh, I always do this backwards. If two segments, or angles in our case, are congruent, then they have the same measure. If and only if lets you flip-flop the order, make the converse of it. If two angles have the same measure, then they are congruent. Definition of congruent. That's a U. Spell it right. Definition of congruent. Now you can put in your single arc marks. Did we have to do that angle first? Didn't have to, but it was kind of the most obvious one. Now we got to work with this angle in the middle. This angle in the middle here, you're going to be tempted to call it angle Q, but you can't. Can't call that angle Q, because how do I know which Q you mean? There's an angle Q here, there's an angle Q here, an angle Q here, and an angle Q here. There are 4 angle Qs. Don't call it angle Q. Call this one angle PQR, or RPQ, doesn't matter. Oops, I'll go back to blue. Angle RQP, or PQR, is congruent to angle. Same thing here. Order doesn't matter on the angles as long as the Q is the vertex in the middle. NQM, or MQN, doesn't matter. Remember what kind of angles those are called? It's in here. Go find it. Cheat sheet page 4. Hopefully you don't need these on the cheat sheet. We've used these angles so often. But please look on your cheat sheet and spell vertical correctly. Not vertical. It's not C-L-E, it's vertical angles. Vertical angles. So we have our 3 sides and we have 2 of our 3 angles. Let's put our heads together and see why this angle R, which is the 3rd angle, could possibly be congruent to angle N, which is the 3rd angle on the other side. Why could our 3rd angle over there be congruent with our 3rd angle over here? I have an idea. How about the 3rd angle theorem? The 3rd angles theorem lets your 3rd angles be congruent. Could these 2 have gone in a different order? We picked vertical angles first and then definition of congruent? Yep. Could you put this angle first? No. How do you call it the 3rd angles theorem if you put the 3rd angles first? It has to come last. There's your 3 missing parts. Now it says go ahead and write a congruent statement. Triangle. Pick it whatever you want. I'm going to call it triangle PQR. Why did I so happen to choose PQR? Because I went single, double, triple. So over here I have to go single, M, double, Q, triple, N. There's my congruent statement. Okay, this one I want to point out, because if we were doing full out actual proofs, this is what it looks like on your assignment. It gives you information written out and tells you that you have to prove the triangle is congruent. Well, all of that information written out is in markings over here. If it's not, if they didn't give you the actual markings, you would have to put them in. So when you see AD is congruent to CB, you're going to put AD, put that single tick mark with this one, CB. And then when you see segment DC congruent to AB, you're going to put the double and the double. If it's a blank slate and there's nothing on the diagram, you need to read this information and put in your single, double tick marks and single and double arc marks. I already have it marked for you ahead of time. This is what it'll look like in your assignment, on a quiz, on a test sometimes. What it needs you to do is provide the missing information with a reason. We're missing 2 pieces of information. We have 2 sides, we have 2 angles. The missing side, right smack dab in the middle, segment AC is congruent to segment AC. Don't forget to put your segment marks because of the reflexive property. Cheat sheet page 2. We also know that angle D is congruent to angle B. I don't know if I have to give you any more hints. Go triple, triple. Why is angle D congruent to angle B? Because, once again, of the 3rd angles theorem. Prove that triangle ACD is congruent to triangle CAB. They already gave us the congruent statement. Why are those congruent? Basically, the definition of congruent figures. This isn't in your cheat sheet, but we had definition of congruent figures at the beginning of chapter 4, section 4.1. Congruent figures has all congruent sides and all congruent angles. We now have all three congruent sides and all three congruent angles. So the definition of congruent figures is how we prove that's true. All right, and lastly, we get to do some real algebra, like the challenging stuff. I know this video is already 20 minutes long, but I gotta show you this because otherwise when you see it in your assignment, you're gonna be totally stuck. If the triangles are congruent, find x and find y. We have a problem in that there's an x and a y in both of these, so two variables. But anytime you have two variables, you can have two equations and you can still solve it. I'm gonna set up my 3x plus 4y and set it equal to, there's a double arc, 100. And then right underneath that, I'm going to set up my 2x plus y and set it equal to 50. There's a chance that you may slightly remember how to do either substitution or elimination and try to find your x and your y. I'm going to do one of each. If you only want to watch the elimination, you can watch me and stop and not look at the substitution. If you only want to do the substitution method, then fast forward through this part and only watch the second part that I do over here. If you want to see them both, because it's a good review and a good reminder, and you're a great student, then just keep watching. Elimination method. We want to eliminate. I'm going to pick this y to eliminate, and I can eliminate this y by turning it into a negative 4y. If I multiply this equation by negative 4, I get, I'll write it in red, a negative 8x minus 4y equals negative 250. Nope, negative 200. You got to keep me on my toes on my math here. Negative 200. As long as you multiply everything by the same number, completely legal. We don't need that anymore. So now I add these down, blue and red make purple, and I add 3x plus negative 8x and get negative 5x. But whoa, what's positive 4 plus negative 4? Positive 4y minus 4y is 0. It's gone. Eliminated. Elimination method, get it? We just eliminated that. Equals 100 plus negative 200 is negative 100. If I take a negative divided by a negative, I get a positive, and my answer, 100 divided by 5, is 20. X equals 20. But that only gives me x. I need to find y, so I'm going to go back up into either equation. It doesn't matter which one. Okay, it kind of matters. If you put it into this one, you're going to have two-step solving. If you put it into this one, you're only going to have one-step solving, or three-step and two-step. So I'm going to go 2 times 20. 2 times 20 is 40. 40 plus y equals 50. If 40 plus y equals 50, then y must equal 10 when I subtract it over. Find x, find y. Fast forward if you don't want to see the substitution. But if you would like to stick around and see it, I'm going to take those exact same two equations, starting with 3x plus 4y equals 100, and 2x plus y equals 50. I'm going to turn this into just y, minus 2x from both sides. So now you have y equals 50 minus 2x. Or if you're having some sort of weird deja vu, negative 2x plus 50, you could put it in y equals mx with b form, but you don't have to. Now I know that y is exactly the same as 50 minus 2x. If y and 50 minus 2x are the same, I can take this y out and put 50 minus 2x in its place because they're equal. Hey, we have the substitution property in our cheat sheet too. That's what we just did, substitution property. But to solve this, obviously it's a lot longer and more steps than the elimination. You would have to distribute the 4 here and here. Then you would combine like terms and get negative 5x. And if you subtract 200 over to the other side and get it out of there, you get negative 5x equals negative 100. What's negative 100 divided by negative 5? It's 20. Looks familiar, doesn't it? How do I find y? Once I know x using substitution, you put it right there, right in our parentheses where we solved for y in the first place, and it says y equals 50 minus 2x. 50 minus 2 times 20. 50 minus 40 is 10. Yes, you do have a couple of those on your assignment, so you're going to try it. Substitution or elimination, your choice, or you can do one of each. There we go, long notes, section 4.2, day 2, working with proving triangles.